Welcome to day 20 of our Python course. Today we will dive into modules and packages in Python. We will start by understanding what modules are, how to work with standard libraries, how to create custom modules, and we will finish by exploring packages. We will also walk through practical examples to help reinforce these concepts. Let's begin with an introduction to modules. A module is simply a file containing Python code that can define functions, classes, and variables. Using modules helps us organize our code, making it reusable and more maintainable. This allows us to break our code into smaller, manageable pieces, improving readability and reducing complexity. Python comes with many built-in modules that we can use directly in our code. For example, the math module provides a wide range of mathematical functions. To use it, we can simply import it using the import statement. For instance, using import math, we can call the math.sqrt function to compute square roots. Alternatively, if we only need specific functions, we can import them individually, like this. From math, import sqrt, pi. Python's standard library includes a variety of useful modules. The OS module allows us to interact with the operating system. SYS helps us manage system-specific parameters. Datetime handles date and time, and random generates random numbers. Here's an example of how you can use the OS module to get the current working directory. Import OS followed by print os.get cwd. Now that we have seen built-in modules, let's look at how to create custom modules. To create a module, simply save your Python code in a .py file. For example, let's create a file called mymodule.py with a function greet name. Then to use this module in another script, we mymodule.greet the name. When you create a module, sometimes you may want to run certain code only when the module is executed directly, not when it's imported elsewhere. This is where if underscore underscore name underscore underscore equals to underscore underscore main underscore underscore comes into play. Code inside this block runs only when the script is run directly, not when it's imported as a module. Next, let's explore packages. A package is a directory that contains multiple Python modules along with an underscore underscore init underscore underscore .py file, which signifies that the directory should be treated as a package. Packages allow us to group related modules together. For example, imagine a package called myPackage containing module1.py and module2.py. To use a module from a package, we can use the from keyword. For example, to import module1 from myPackage, we write from myPackage import module1. Then we can use the functions or classes from module1 in our code, such as module1.sum function. Let's take a practical example, creating a banking system package. Imagine a directory called banking system containing two modules, account.py and transactions.py. The account.py module defines an account class, while the transactions.py module contains functions to deposit and withdraw money from an account. In account.py, we define an account class with methods to display account details. In transactions.py, we define functions like deposit and withdraw to modify the balance. You can then import and use these modules in a separate script, providing a simple yet powerful way to manage related functionalities. When working with modules and packages, there are a few best practices to keep in mind. First, always choose descriptive names for your modules and packages to make your code easier to understand. Organize related modules into packages to ensure scalability and avoid circular imports where modules depend on each other in a loop. Now it's time for a mini project exercise. Your task is to create a package called math operations with modules for basic operations like addition, subtraction, multiplication, and division. Test your package by importing and using the modules in a separate script. This will give you hands-on experience in structuring and working with packages.